A brand new island just rose out of the ocean off the coast of Trinidad, and scientists say it wasn't there a month ago. It's not made of rock, and it didn't come from a normal volcano. It's made of mud, forced up from beneath the seafloor, and geologists believe it was triggered by the same catastrophic earthquake sequence that devastated Venezuela back in June. The island rises, about 4 meters above the water, roughly 13 feet, and it's already being torn apart by the waves. Scientists estimate a third of it eroded away within days of forming. Today, we're breaking down exactly what a mud volcano actually is, why this one appeared right now, hundreds of kilometers from the earthquake's epicenter, and what it tells us about the hidden aftershocks of a major seismic event that most people never hear about. No guessing, no dramatizing, just the facts, the science, and the real stakes. Drop a comment right now. Had you ever heard of a mud volcano before today? Tell me what you thought when you first saw the word. If you want to be the first to know every time something major happens geologically, subscribe to the channel right now. It is completely free. A thumbs up also helps enormously. Let's go for 5,000 likes on this one so the algorithm actually shows it to the people who need to see it. Thank you. Now, let's get into it. What actually appeared off Trinidad? In the days following the devastating magnitude 7.2 and 7.5 earthquake sequence that struck northeastern Venezuela on June 24th, 2026, a story we covered in detail on this channel, a strange new formation began appearing along Trinidad's southwestern coastline, roughly 2.5 kilometers east of beach camp near the town of Palo Seco. Geoscientist Xavier Moonen, who examined and documented the feature, identified it as a newly formed mud volcano island sitting about 3.3 kilometers from an older, already known formation called the Anglais Point Mud Volcano. The new island rose approximately 4 meters above the ocean surface in water only about 12 meters deep, and was composed of soft clay, embedded rock fragments, and high calcite sediment, along with a noticeable smell of hydrocarbons and visible gas bubbles. At the site, all consistent with material being forced upward from deep underground rather than deposited by normal coastal processes. The original extrusion covered an estimated 500 square meters when first documented, but almost immediately, wave action began tearing it apart. Within days, Moonen reported that roughly 1/3 of the islet had already eroded away, and researchers noted the erosion appeared to be accelerating, meaning this new island's time above the water's surface is likely to be measured in weeks or months, not years. This wasn't the only unusual coastal change reported in the area. Around the same time, the coastline at nearby Galfa Beach in Cedros was reportedly uplifted by approximately 20 feet, a dramatic vertical shift in the land itself, further evidence of just how much stress the June earthquake sequence sent rippling through the fault networks connecting Venezuela and Trinidad. And what a mud volcano actually is, despite the name, and despite genuinely looking like a small volcanic island from a distance, a mud volcano has essentially nothing to do with the molten rock volcanoes we've covered on this channel before, like Kilauea in Hawaii or Mayon in the Philippines. There's no magma involved at all. Instead, a mud volcano forms when underground pressure, sometimes from trapped natural gas, sometimes from overpressurized groundwater and fine sediment, builds up beneath layers of rock and clay until it finds a weak point, like a fault line or fracture, and forces its way to the surface, carrying soft mud, sediment, and gas up with it. In southern Trinidad specifically, this isn't an exotic or one-time phenomenon. The region sits above what geologists call the Southern Basin, an area shaped by millions of years of petroleum geology, where oil and gas deposits sit beneath layers of soft, unconsolidated sediment. That combination, hydrocarbons and pressurized sediment beneath weak surface rock, is exactly the recipe that produces mud volcanoes, and Trinidad has one of the highest concentrations of documented mud volcano activity anywhere in the world. Locally famous examples onshore include the mud volcano field, often referred to as the mother of mud volcanoes at Palo Seco, which continuously releases gas that keeps its mud slurry constantly agitated even without a triggering earthquake. Why an earthquake? In Venezuela could trigger this in Trinidad. This is the part of the story that connects directly back to the earthquake science we've discussed on this channel before. Trinidad sits near the boundary between the Caribbean plate to the north and the South American plate to the south, the same tectonic boundary responsible for the devastating Venezuela earthquake sequence in June. NASA's newly operational NISAR satellite, which uses radar to measure ground displacement with extraordinary precision, was activated for its urgent response earthquake monitoring system for the first time since entering orbit, specifically to map how much the ground shifted during the Venezuela earthquakes. That data showed the fault rupture traveled from the town of Mayon, continued offshore, and came back onshore near Caracas's international airport, with the ground south of the airport shifting by as much as 60 centimeters, nearly 2 feet, in a single event. An earthquake of that scale doesn't just shake the ground directly above its rupture. It sends seismic energy traveling outward through the connected network of fault splays and fractures across the wider region, including south toward Trinidad. According to the University of the West Indies Seismic Research Center, which has been analyzing the Palo Seco Formation, mud volcanoes like this one form specifically along underground fault splays, and researchers identified the Santa Flora Fault, located less than a kilometer from the new island, as a likely pathway connecting this event to the broader seismic activity triggered by Venezuela's earthquakes. When strong shaking travels through ground already saturated with pressurized gas and fine sediment, it can act like a trigger, essentially shaking loose material that was already primed to erupt, forcing it upward to the surface along the path of least resistance. This has happened before. If this sounds like an unusual one-off event, Trinidad's own geological history says otherwise. This is actually the second time in less than a decade that a mud volcano island has appeared off Trinidad's coast following a Venezuelan earthquake. In 2019, a similar formation surfaced roughly 5 kilometers off the coast of Mayon, Trinidad, triggered by a magnitude 6.0 earthquake in Venezuela's Gulf of Paria. That island persisted for approximately 4 months, before erosion eventually reduced it back down to a submerged shoal beneath the waves. Local residents and geologists in the region have documented similar temporary mud volcano islands appearing after major seismic events going back generations, with notable formations. Recorded in 1911, 1928, 1964, and 2001, each tied to periods of elevated regional seismic activity. In August 2018, a magnitude 6.9 earthquake in the region caused the beach at Galfa to uplift by over 3.5 meters, a smaller but similar version of the coastal deformation reported this time around. Researchers from the University of the West Indies, Seismic Research Center, the Institute of Marine Affairs, and Resilog Limited are currently collecting and analyzing samples from the new Palo Seco Formation to determine the exact age and origin of the material, work that will help confirm precisely how directly this event connects to the June 24th earthquake sequence versus other ongoing background seismic activity in the region. Why scientists are watching this closely. Beyond the pure novelty of watching a new island briefly rise and then erode away, scientists have practical reasons to take formations like this seriously. Xavier Moonen specifically noted that while this particular islet's rapid erosion suggests it won't last long, the underlying geological process that created it remains active, meaning future seismic events in the region could trigger additional mud volcano activity along the same fault network. This matters because mud volcano eruptions, while generally far less immediately dangerous than magmatic volcanic eruptions, aren't always harmless. In some cases elsewhere in Trinidad, newly discovered mud volcano craters bubbling up in residential areas have prompted local authorities to prepare evacuation plans for nearby families as a precaution, since sudden high, more energetic mud volcano eruptions can occasionally release enough gas and material to pose a real, if localized, hazard to structures and people nearby. For seismologists, mud volcano formations like this one also serve as a kind of visible physical confirmation of how far and how forcefully stress from a major earthquake can travel through a connected fault system, sometimes producing visible surface effects hundreds of kilometers from the original rupture, in a country that wasn't even the primary disaster zone. What happens next? Based on the rate of erosion already observed, researchers expect this particular mud volcano island to continue shrinking under wave action, likely disappearing back beneath the surface within weeks to a few months, similar to the 2019 Mayon formation's roughly 4-month lifespan. Sample analysis currently underway from the University of the West Indies and partner organizations should provide more precise confirmation of the material's origin and a clearer scientific record connecting it definitively to the June earthquake sequence. Meanwhile, the broader seismic monitoring of the Caribbean plate boundary continues, both in Venezuela, where recovery from the earthquake's catastrophic human toll remains ongoing, and across the wider region, where scientists are watching for any further indications of continued stress release along the connected fault network. Final thought. A newly formed island rising out of the sea and slowly dissolving back into the water within weeks sounds almost like a myth, but it's a genuine documented physical consequence of a fault system releasing enormous stored energy hundreds of kilometers away. It's easy to think of an earthquake's damage as confined to the immediate area of violent shaking, collapsed buildings, and the human toll we've covered in Venezuela. But this small, temporary island off Trinidad is a reminder that the energy released by a major earthquake doesn't simply stop at the edge of the strongest shaking. It travels outward through connected fault networks, sometimes surfacing in strange and unexpected ways, in this case, quite literally, as new ground rising briefly out of the sea before the ocean reclaims it. We will keep tracking this story and every other major seismic and volcanic event happening around the world right now, subscribe so you don't miss the update on what the sample analysis reveals, and leave that comment below. Had you ever heard of a mud volcano before today? Tell me what you thought when you first saw the term. 5,000 likes on this video. Let's go. See you in the next one.